Welcome back. In this video we'll start to discuss something that we may or may not use in the course, but it's really good information to have. So and if anybody has any plans to be a professional C++ programmer, this is definitely something that comes up, or even a C programmer. So let's dive right into it. We will create a new C++ project. And the name doesn't really matter a whole lot. We'll create a new main.cpp and then fill in all the normal stuff. Let's include IOStream, and then we may or may not use strings, so let's just include that just in case. And some of you may or may not have learned this, what I'm about to discuss today, in COP 2000, so that's fine. I'll start sort of from the beginning. Okay, so this is relating to functions and pointers, okay? And so let's create a quick function and let's have it return an integer, and let's just call it add numbers, and it will take a number. It'll take an integer a, it'll take an integer b, and it'll return some integer. Simple enough. And so we create integer I and j, and then we give those some values. We'll say I equals 1, j equals 2. Then we will call our function add numbers. And I'm going a little fast because this is all stuff that we've reviewed and you should probably have a general sense of at this point. So if there's any, and these are videos as well, so you can always go back. That's the beauty of videos. So we have that, and then let's make an integer called result, and then result will store the result of our adding of two numbers, and then we see out, and then let's say the result is save it. Let's run it, make sure we're good. Oh, let's not forget to do this to make sure our DOS prompt doesn't go away immediately. Okay, so the result is 3. Everything about that makes sense. One of the things we sort of just glossed over and didn't really go over the details was what actually happens when we pass integer a and integer b to this function. Well, as we discussed earlier, we have there are two parts to our program variables. They are the variable name, the actual identifier, the address, the sort of everything but the actual data that's contained, and then the data inside. So in this case we have I, and I is available at some memory address, and if we wanted to print that memory address we could do ampersand I, and it would tell us the exact address, and then within that address contains 1, and so the same thing here, and then we have a result. And so what actually happens when we call add numbers, we pass it a copy. We don't pass it the original. And so what happens is when we call add numbers, now if we were looking at our computer memory, we would have two instances of 1. So we'd have I right here, and then we pass it to add numbers, and that makes a copy, and the computer does all that automatically. The operating system and the C++ compiler all know how to take care of that. And then so when we're here, this isn't the original copy. This is a copy of A. So if we were to do something and modify it, let's play a little bit here. Before we return, let's say, well, let's add a little bit of code here. and then we'll return the result. So all I'm doing is modifying the program slightly here, nothing crazy yet. So let's say that we set A to 7. Well, a couple things to note. This calculation has already been done, so this result is stored. So changing this to 7 right here does not affect result. So that's one thing to note. But more importantly is I equals 1 here, and I is still going to equal 1 after this. So let's go ahead and let's wipe this. I don't want to get too complicated here, so we will make a void function called change number. Sometimes it's just easier to start with a clean slate. And then that will take some integer a, and let's get rid of some of this extra code here. Let's just start with I equals 1. We're not worried about calling that. Okay. And then we'll display the result of I, or I'm sorry, the value of I. So I is some number. So what do we well, let me finish writing our function here, and then our function will say A equals 7. That's all our function does. Okay? So top to bottom here, our program starts in main. Don't forget that. The first function that's executed in our program is main, and then so we declare I, and that gets some space in the computer's memory, and then we set I equals to 1, and then we say I is equal, and then our computer, our operating system, will go to that memory address of I and pull the value, and it'll be 1, and so everything will work great. So it'll say I is 1. And then let's run that to make sure we haven't made any syntax errors, and I is 1. Everything's fine. So what if we call change number? What happens then? Well, let's pass it I, and then let's do another cout afterwards. So let's stop for a minute and ask ourselves, what is I going to equal after this function? So let's run it, and then we'll explain why things are the way they are. Okay, so I is 1 before the assignment, and then I is I should say before the function runs, and then I is 1 afterwards. And so the reason for this is we don't pass it the memory address, we pass it a copy of I. So anything we change in here is not going to change the original. So that's interesting to know, because sometimes we do want to change the original. So say we have a car struct, or a car, let's not get into structs yet, although they work pretty much exactly the same way. Let's just use our change number. So we have something we want to do to a number, and we want to change the original. We've got some big complex algorithm we've come up with, and they pass us a number, and we want to change that original number. So what we have to do is actually use a pointer. And what that does is, instead of passing a copy, it passes the memory address. And so what happens is we instead are operating on memory addresses. And so, like our example previously, and let's to make sure this is large enough, somebody taught me a keyboard shortcut the other day to make this larger, so hopefully that helps a little bit. Although I haven't really received any complaints so far, I wanted to make sure everybody can see this as clearly as possible. So let me go a little bit smaller so we can still keep some screen. Okay. So what this will do is this is our dereference operator, and so it goes to the memory address, it changes it, and since we're dealing with memory addresses, that's always the same. Our program always deals with the same memory addresses. We don't We don't pass copies of that around or anything. That's a memory address is sort of an absolute thing. The address 1000 is the same whether you're in main or in void or anywhere in your program. 1000 is always going to contain some data, and in this case that address is going to contain our integer. So let's do some examples here so we can see our little squiggly underline, and maybe I will make it a little bit bigger so you can see these sorts of things like our squiggly red underlines. So what we did is we changed our function to now take in a memory address, a pointer. So we have to change it down here as well. So what we're going to do is we're going to pass the address of I. So this notation may seem a little funky to you, but just kind of memorize it. When you're dealing with your function definition, you use this notation like you're declaring it, because that's essentially what you're doing. You're declaring a variable that it can be taken in by this function. And when you're passing it, well, we don't want to pass the value of I, we want to pass the address of I. And so now if you were to think about it, you say I is going to be 1 here as normal. But then what's going to happen is this function is going to go all the way in and peek into the location of memory where I is stored, and it's going to change it directly. And we're not passing a copy of I anymore, we're passing a memory address, and because memory addresses are absolute, he knows how to directly manipulate that memory address, and then here we're going to have a different value of I. And now we can see I is 7. So what I'm going to do is I'm going to cut the video a little short. You might want to, if that doesn't make sense, watch it a couple times, because one of the cool things we can now do is do that with, instead of simple variables, we can do it with structures. And structures are very similar, but we may work with this a little bit when we get into our data structures, but this is actually a very commonly used practice when you get into C and C++ programming. So this will be part 1 of 2.